Today we have to learn some chemistry based chapters. Our first chapter is matter in our surroundings. So let's get started. So first of all, what is matter? In our surroundings, everything is matter. If I take this pen, this is a matter. If I take this board, whiteboard, this is also a matter. So matter means elaborately a thing that have some space. So what is space? This is a pen and it has some space. If I remove this pen from this area, there is nothing. There is nothing in this area. So elaborately, this is a matter which have some space. In a scientific sense, mass and volume. So what is mass? So what is mass? If I take this pen into a weighing machine, you can see this is a weighing machine. Weighing machine means if I put this pen to this machine, this will give you a specific reading. So means it gives you a specific mass. So this is the mass. And volume, if I take this pen, it has some breadth, some height and some length. So on the basis of this, you can see this, it's a matter. As for example, if I take this chalk, this is a chalk, right? Everybody knows that it's a chalk. So if I break this chalk, what will happen? This is a small piece of chalk. If I continuously break this chalk, it will get some dust. So it will get some chalk dust. Chalk dust. So this is the smallest particle of the matter. If we break the building, right? So what we can get? We can get a small brick. So every matter has some small part, which is particle. You have to remind that, which is particle. This is the smallest part of a matter, right? So now, if there is a beaker and there is some water, if I add some chalk dust, what will happen? After some time, you can observe that the chalk dust is not miscible in this water. But if we take another beaker and get some water and add some sugar solution, sugar, everybody know what is sugar? So if we take sugar or salt, sugar or salt, salt means NaCl, right? So if we take sugar or salt, it will miscible, that means it will be dissolved into that water. So difference between this chalk and the NaCl, that means the salt, what will be the difference? Can you just see exactly what chemistry behind this? So now this is a water molecule. Water molecule, water, we all know what is water? H2O, right? H2O, and this is the structure of the water molecule. Now when we add salt, that is, just now we have said that NaCl, this NaCl will break into Na and Cl. This Na and Cl will enter into this water molecule. This water molecule and have some another solution. So there are new term comes, that is solution. So from this we can elaborate, we can state a statement that NaCl or sugar can dissolve into water. So from this another question arrives, how can this possible? This possible because these are some smallest particle. These smallest particle can enter into the water molecule, but in case of this has not been dissolved in the water because the particle of the chalk. So we can write it here. We can write it here that the particle of the chalk, particle of the chalk is greater, that means larger than the particle of the NaCl, right? So now what you can see characteristics of particle. So now we can get what is particle, we just discussed that. So now what characteristics of particle? First point we discussed that particles have some space, that from the difference between the chalk dust and the NaCl, we can exactly elaborate or illustrate this statement. This is most important statement. Okay, so particle have some space. Now the second one, you can see particles are in a motion. So you can easily observe if there is an incense stick. You all know what is incense stick is. So incense stick, if you a burnt incense stick, if you put in a corner of a room, after some time what you can get? You can get some smell of the incense stick, right? Always you remember the incense stick, when it is burnt incense stick, it has some burnt gas, smelly gas, right? So smelly gas, if there is a distance between incense stick and yourself, how it is possible? It is possible because of the motion of the particle of that incense stick, right? So this is the second term, the observation we can get, particles are in a motion, right? Another example, if there is a beaker, if we get some water into that beaker and you can put some ink, right? What will happen? The ink after some time will spread into that water. So what science behind this? This is because like with the incense stick, this ink will distribute it in the water molecules. So this second, particles are in a motion, has been proved. Now the third and the last one, another most important, particle attract each other. This is so funny, na? So particle attracts each other. So again, this is a chalk particle. If we break this, something we have to break means the thing are in a attraction position, attracted, all the particles are in attractive position. If there are 3 students, right? You can imagine or you can state this in your school or classes or whatever. So if there is a 3 students and all the 3 students are in a hand lock position, then what will happen? I as a teacher, we can't break that chain. So if there is a this is a student 1, student 2 and student 3. If there is a hand lock position, that means like this hand lock position, that we have to break this chain. If I take one of the students from this, so break means firstly they have to be in a chain position, right? So this is the third one, particles attract each other. If we break this building, there is a lots of building here, so we have to break this building for some innovation or modification. So first of all, it has to be in an attracted position by the bricks. So if we can see for the building purpose, there are lots of bricks, first brick, second brick, third brick, and this is attracted position between the bricks with the help of cement. We all know that. After this we can prepare or we can build a building. So from this we can easily say that particles attract each other.